Welcome to JCE Connect. We are discussing on stopping sight distance. In the earlier lecture, we had seen sight distance, restriction to sight distance, and types of sight distances. In today's presentation, we'll discuss stopping sight distance and we'll see one simple example on this stopping sight distance. We know sight distance is visibility, and stopping sight distance is nothing but the minimum sight distance required to stop the vehicle safely without collision with any other obstruction, for which the vehicle should be traveling at a design speed. So if we put in proper words, it is the minimum sight distance available on a highway at any spot should be of sufficient length to stop a vehicle traveling at design speed safely without collision with any other obstruction. It is also known as non-passing sight distance. It is understood in two parts, that is lag distance and braking distance. First, lag distance is the distance traveled by the vehicle during total reaction time. When the driver sees an object, an obstruction or opposite coming vehicle, that time he reacts, that the reaction time is lag distance, which is equal to 0.278 times velocity into reaction time. And that reaction time is 2.5 seconds for stopping sight distance and 2 seconds for overtaking sight distance. And the next one is braking distance. It is the distance traveled by the vehicle after application of brakes to a dead stop position, that is skidding of vehicle. The vehicle will not stop immediately after you apply a brake, right? As it is in momentum, it will travel certain distance immediately after application of brake. So that distance is called as the braking distance, which is equal to v square, which is directly proportional to the velocity of the vehicle and inversely proportional to the coefficient of friction between the tire and the road surface. And this coefficient of friction is inversely proportional to the speed of the vehicle. Means at lesser speed coefficient of friction is more, and at higher speed the coefficient of friction is less. So our total stopping sight distance is equal to lag distance plus braking distance, where n is in percentage gradient, whether it is a up gradient or down gradient, whether you are climbing a hill or coming down. So if it is an ascending gradient, we take a positive sign, and if it is a descending gradient, we take a negative sign for the calculation purpose. And the unit of SSD is in meters. So here we'll take one simple example. So here he is asking you to calculate the minimum sight distance required to avoid a head-on collision of two cars approaching from opposite direction at 90 kmph and 60 kmph. Assume reaction time, he has mentioned. If he has not mentioned, we should assume for SSD it is 2.5 seconds, and coefficient of friction he has mentioned as 0.7, and the brake efficiency of 50% in both the cases. So in the given problem, he has given us the reaction time 2.5 seconds, coefficient of friction as 0.7. Also he has mentioned that brake efficiency is 50% of its coefficient of friction. So F is equal to 0.7 and its 50% is 0.35. And he has given us the velocities of both the cars. That is, first car is running at 90 kmph, that I am converting in meter per second. So 90 divided by 3.6 is to 25 meters per second. And similarly for car 2, it is running at 60 kmph and its speed is 16.67 meters per second. And we know the formula for stopping sight distance is equal to Vt plus V square divided by 2GF. So here we are seeing the formula is in meters per second, and another formula, that is 0.278 Vt plus V square by 2GF percentage n, that is in terms of kilometer per hour. So this is converted, here we are taking small v, take the values, it is coming out to be 153.6 meters. And similarly for car 2, it is 82.82 meters. As he has mentioned, head-on collision, both the cars are coming in opposite direction. So for car A requires 53.6 and car 2 requires 82.2. So if you want to avoid a collision, then we need to add these two side distances. So that will be the total side distance required to avoid the head-on collision of two approaching vehicles is 153.6 plus 82.2 is approximately of 236 meters. With this is the safe distance. More than 236 meters or minimum of 236 meters will avoid head-on collision of these two vehicles coming at 90 kmph and 60 kmph.